Chapter 4, Lesson 4 of Pre-Calculus, and I want to wrap up the transformation discussion of these sinusoids in this video where we look at the horizontal shifts right or left and then the vertical shifts up or down. And then I'll do a video where I do a number of examples where we graph a number of these, putting all of these values together so you see how they work. So let's begin by talking about the horizontal shift right or left. We know from previous functions that if we want to shift a function right or left, we subtract the shift from the x value. So if I have x squared and I want to move this 3 units to the right, I do x minus, and then I put the shift in here, and then I put it in, enclose it in parentheses to indicate that this is a shift horizontally of 3. If I want to then shift it up or down, I put the vertical shift on the outside. So this is a horizontal shift right 3, this is a vertical shift up 2. The same procedure is going to take place with the sinusoids. So if I have the sine function and I want to shift it to the right pi units, I would go minus pi, and then I would wanted to shift it up 3, I would add that on the outside, and so I have a horizontal shift on the inside here like we've done before, and I have the vertical shift on the outside like we've done before. Okay, now let's talk specifically about this horizontal shift. The horizontal shift, okay, which is different than a shrink, in terms of a sinusoid is called the phase shift. Okay, so when we're talking about shifting a wave right or left, we call it a phase shift when we're looking at sinusoids. Okay, so again, that's a vocabulary word that we need to know, but just understand it's simply another way to say we're shifting this function to the right or left. Okay, now there's something very important that we have to discuss in here, and that is the horizontal stretch or shrink that we talked about in the previous video affects the horizontal values or the x values on the horizontal axis of the function. The phase shift moves those horizontal values. Now when you have both happening, where you're moving the horizontal values right or left, and you're also horizontally stretching or shrinking that, both of those affect the horizontal stretch or shrink affects the movement of the function right or left. So if it affects it graphically, it's also going to affect it algebraically or in the equation. So let me show you what I mean. Let's say we had the expression 3 theta minus pi. Okay? Now, we notice that there is a horizontal shrink of 1/3 going on right here. And because it's horizontally shrinking, it's also affecting this shift that I see as to the right pi units. And in actuality, I can't really see for sure what the shift right or left is as long as this value is in front of theta. In other words, in order to see the shift like I see it here, the value in front of theta here is a 1. And in order to correctly see the shift, this value must be a 1. So because it's not a 1, I must algebraically make it a 1. So what I'm going to do is to factor out this 3, or I'm going to divide both of these by this value that's here. So that's going to give me then the 3 on the outside, theta minus pi over 3. Now that this horizontal factor is on the outside, I can accurately see what the actual shift was. And the shift is actually to the right pi over 3 units with a horizontal shrink of 1/3. So whenever you have a value, a b value, that is not 1, in order to correctly see the horizontal shift, you must factor that value out so that you can properly see what not only the horizontal shift is, but the horizontal stretch or shrink is, but what the horizontal shift is as well. And then if you had a value out here, you would continue to have this. So it's very important that when we're looking at these phase shifts, that if there is a horizontal shrink involved as well, those are affecting this shift. Therefore, I need to factor that out in order to properly see the shift. Okay? So that takes care of all of the transformations that we have discussed. So let me put them together in the general form to kind of sum everything up for us. So the general equation of y equals sine theta, if I were to add all these shifts in and their appropriate letters, it would look something like this. The amplitude is the letter A. We then have the sine. We then have this b value that's been factored out of theta minus h, okay, all of that plus k. And you remember h and k from our earlier discussions. H was the shift horizontally, right? And k was the shift vertically. So this is what the general equation looks like. So what your job is to know what this is and how to calculate it. To know what this is and how to calculate it. To know what this is and how to calculate it. And to know what this is and how to calculate it. How to find it from a graph, from a table, or from a word problem. Remember, verbally, this is the max. Come on. Uh-oh. My computer just decided to freeze up. All right, there we go. Come on back. To calculate the amplitude, I find the max minus the min, and I divide it by 2. In order to calculate b, I can use the equation the period is equal to 2 pi over b. So if I know what the period is, from a word problem, from a graph, or from a table, I simply put the period value here, and then I solve this equation for b, and then I can then substitute the value in. The phase shifts, we'll talk about more how to decide which value to use, sine or cosine, shift right or left, and how far. And then the k value is going to be if we need to shift that center line up in order that it is going through the center of the wave, because the wave has been stretched or shrink or moved up, depending upon what it says, again, in a word problem or from a graph or one of those things. Now this k value can be calculated using the same values we use for the amplitude. In other words, the k value we can actually calculate by taking the maximum value of the function, adding it to the minimum value, and dividing it by 2. So we didn't talk about that much when we were talking about the stretches, or I'm sorry, the shifts, but I'll put that in there now, that this k value can be determined by taking the max plus the min and dividing by 2. So you can see if we just put these three little equations in our minds and remember those, and then the h becomes just a shift right or left depending upon what kind of function we choose to use, and we'll talk about that when we look at a word problem. Calculating and putting these values in is not that difficult. So when you're reading a word problem, you're looking for max, you're looking for min, and you're looking for period. How long does it take to go through its cycle? What's the highest? What's the lowest? You get those three pieces of information, and you have everything you need to calculate or to come up with the equation for that problem. Okay? So we'll take a look at those. We'll graph a couple of them in the next video, and then I'll probably do an example video, and then we'll look at applying these to some real-life problems.